Good morning. How are you? Mike is doing good today. That's good. Thank you so much for being here. I really appreciate it. First, because it's super early, and yes, I'm not a morning person, so I appreciate your being here with this good energy. And also, at the exact same time, there are 3 other amazing talks by amazing speakers and people. Friends of mine, so thank you for choosing to be here, and probably we'll have some viewing party in order to not miss the rest, so let me know if you want to join. Today, I am going to talk about Kotlin Multiplatform. If you were at the keynote before, you heard a lot about that. And this talk, so this conference would have a lot of talks about multi-platform in general, libraries that you can use, specific parts of it that I'll mention through this talk. But this is a very high-level introductory talk. So I will mention a little bit after the other talks in this conference that you can go to in order to go deep dive into specific parts. But if this is the first time you hear about Kotlin Multiplatform, if you heard about it but didn't start working, are not sure if you want to do that or not, if you're just started to explore anything like that, that would give you a high-level overview about what it is and why should you maybe start looking at it. Yeah, so this is kind of to set the expectations to what this thing is. So, hi again. My name is Britt Barak. Haven't introduced myself before. I work for a company called Nexmo that was acquired by Vonage. So now I work for Vonage, I guess. And we have a lot of communication services. So like APIs at SDK for SMS, phone calls, IP calls, WhatsApp, video calls, all this kind of stuff. I manage our conversations products. So it's an omnichannel product for all of these channels together that we have. Oh, it's got dark. So romantic. So we have. So I manage our conversation products that we have Android, iOS, JS, SDK, and a backend API that essentially allows you to do all of these different communication channels together with one product. And then also we keep the context, the events, in order to so that you can do cool and interesting conclusions on this communication interactions. So, as you can understand, we have a lot of different platforms that we work on in the same team. This is just a few of the wonderful engineers that I get to work with every day. Yeah, so we have one product, but a lot of different platforms that we want and need and do support. So this is kind of what we got into looking at multi-platform and started to work with it. More about that in a few minutes. So this is part of my team with one exception. And actually, I think maybe the favorite person in this team is this lady called Emma. She's one of my really best friends. She's an amazing mobile engineer. A few months ago, she decided to leave the team. And as all of us are really good friends, we decided to throw her a really cool goodbye party. The thing is that my team, as amazing as it is, we're super good at writing software, not very good at organizing parties. So we decided to write an app, obviously, with our product, our SDKs, in order to organize this goodbye party for Emma. So the app is going to look something like this. This is like the different tasks or like different items that we need to buy. So each person in the team can add different items like balloon, drinks, things like that that we need to get. And then each person gets an item or each item gets a person who's in charge of it. And for each item, though, we want to collaborate and help each other to organize. So for each item, we do like this. Anyone in the team can communicate about it. So we can write messages. Yorgo is in charge of the balloons, but I can tell him, hey, if you find red, these are the best type, the best color, and then he can send message backs. All of us can see the messages. We can send photos, and also we can do phone calls and things like that. So this is kind of the app that we wanted to create. Now, as I mentioned, we're going to use our platform in order to do it. And in our platform, the data model, so in our backend, the data model looks something like this. We have a conversation object, which is a conversation in the very essence of it is a container of members who are the people who take part in the conversation, in this case, the team. And a list of events, communication events, interactions between the people in the team, the different items, the phone calls, all of that are different events. In our data model, we save the events chronologically. So we have a list of events ordered by the time they were sent. But as we saw, this is not exactly what I want to do in the app. This is not how I really want to present it. So what we would need to do is to take this list of events and then to sort them, right, in order to present them in the way that we want it. So this is kind of how the app is going to be designed, let's say, or this is what's going to happen in the code. In a very high level, we'll have somewhere a callback, an on-new event, for example, callback, that whenever we get a new event, so whenever someone sends any new event, a phone call, a message, an item added to the list, anything like that, we'll get the item, we'll get the event. Then we would need to parse it, right, to understand which type of event is it. And then we would need to sort it in order to know where to present it. We would need to understand where should it be in the list of the presentation. And then we will present it on the app itself. So if I think a little bit about the architecture of my app, I know all of you do as well, then I would probably want to separate the logic, so in this case, the parsing and the sorting, which is kind of the logic, the brain, it doesn't really need to have a platform-specific code, and the presentation, which, if I'm talking in this case about Android, it has to be an Android-specific code, like the views and so on are like very Android-specific things. So I would probably, in one way or another, would want to separate it to make my app, the architecture, robust and testable and so on. So probably that's what I would do. You can guess, probably you already guessed, that Android app would not be enough for us because we all have different type of technologies and different type of phones that we want to use. In this case, we would want to have the same app, the same functionality, also for iOS and for JavaScript, for the web. And if we would start to write those applications, we would probably do something that is kind of the same, right? The presentation, yeah, it would be different because the browser is different than how the iOS app works and present the views and so on. So the presentation would be specific and different. And then I would also want to separate this from the logic or from the parsing and sorting in this case. But from the logic, I would want to separate those anyway. And if we think about it for a second, anything that is not the platform-specific row, so all of the logic row, it does kind of the same thing, right? So the language may be different, but the whole reason for us to separate the platform components from the non-platform components are like, that's what we did. So it worked kind of the same. So it's a different language, but it does kind of the same thing. So how cool would it be if instead of duplicating it, we can have just one component with all this logic that is kind of the same. It can be shared, right? It's a common logic. And this is exactly the idea of Kotlin Multiplatform. So this is what it allows us to do. Two important points. What it allows us to do is to actually share only what you want. So only the code that we want to share, we will share it. And the other code, like here in this case, the presentation, I can also tell you that I told you we do like phone calls and video calls, so you can understand there's a lot of platform-specific things that are going on there. So I can decide what I want to share and what I don't want to share. And also, like, when do we want to share these things? So a lot of people, when first hear about Kotlin Multiplatform, they think about framework like React, like Flutter, Xamarin, this kind of platforms. So a major reason why this is very different is because you don't have to move your entire applications to a different ecosystem, like to a different platform. You can decide when do you want to share, what do you want to share, leave the native and the specific things whenever you want to leave them in the specific platform. I can tell you that for us, it was a big advantage because we already started to work on the SDKs. We didn't want to refactor everything right now. So this allows us to do it in pieces, right? To decide, okay, now we want to do something that is shared, or now we want to refactor, and we can move it to the common model. So that's a very huge advantage that also, I think, gives you a lot of confidence in choosing to play around with it or to start working with it. Okay, so a little bit more about how this works. So the way that Kotlin Multiplatform would allow us to build our applications is to take this logic, the common thing that we wanted to share between the different applications, the different platforms, and to say, okay, this is a common set of source code. We'll see it in a second. But this is a common component, a common library where we have all the shared code in that specific component, that specific place. And then how would we do the separate code? So we would have different targets for each, we call it the target, so for each platform that we want to run on. It is called a target, and a little bit of how it works. So let's start with the Android bit, just for the sake of the example. On our Android devices, where the application run, well, the Android device doesn't really care if you wrote your app in Java or Kotlin or Scala or anything. It doesn't really care. The device has this component called the JVM, the Java Virtual Machine, that knows only how to work with one type of file. And this is the Java bytecode, so classes that end with .class. It knows only how to work with them, to take them and run them, and then you can see your application, in this case, the Android application. So how does the code that we write in Java or Kotlin turns into that, or gets to the JVM? We write our Java code, for example, and then it goes through the Java C, the Java compiler, turns into a Java bytecode file that are sent to the JVM. Same thing, sort of, if we write with Kotlin. So with Kotlin, our Kotlin files would go through the Kotlin compiler that also can read the Java files. And the Kotlin compiler would turn it into Java bytecode that the JVM can understand and can run. And this is how this works for Android. So essentially, we talk a lot about, like it's very common and very popular right now to talk about Android, Kotlin for Android, but what actually happened, it's not necessarily specific for Android, it's for JVM. So the Kotlin has 3 different flavors, and one of them is Kotlin JVM, meaning we can take the Kotlin code, turn it into Java bytecode in order for the JVM to take it and to run it. So this is one type of flavor that we can use. As I mentioned, it's very commonly used for Android, but not only. So any backend or desktop applications that use the JVM, you can use that as well for that case. Another flavor that works kind of the same, in the same manner, but can take the Kotlin files and turn them into JS files that can run on JS, that can run JS applications. Once again, either on the browser or on the backend. So for Node.js, you can do that as well. So we're kind of the same. And the last one, the last target or the last flavor here is the iOS. It is, once again, very common to think about Kotlin Multiplatform, where we do Android and iOS. But what happens there, it's not necessarily specific flavor for iOS, but we have a flavor for, we call it Kotlin native, meaning that we can take the Kotlin code, turn it into machine code, that later on, if you write an iOS application, you can use it as any other framework with like any other binary code can run on the iOS applications. Yeah, but in addition to that, because it's machine code, in addition to that, you can also use that in order to run desktop native, WebAssembly, Android native, and so on. And yeah, for us, this is that's been very an important point, that it's not only for iOS, you can do a lot of different things with it. Okay, a little bit on how to get started. Well, there's a photo of a cake here, because we're in a party theme, but I'll be honest with you and say that this is not a piece of cake to get started. But I think, though, honestly, this is the most painful part, like just to get started, just to have your first project, from scratch to running with the platforms that you selected. So have a few free hours, let's say, in order to do that. But honestly, I promise you that this would be like the most painful part. And I do believe, and I know that it would get better and better very soon, because we see how much effort JetBrains put in, and the ecosystem as well, like put in the multi-platform technology. So how does it work? How do we get started? So the first thing that you need to do when you open your IntelliJ and start a new project is to add a plugin for the multi-platform. So you add the plugin, you say, hey project, you're now a multi-platform project, congratulations. That's the first thing that you need to do. And the second thing would be to add the targets. So it's the same targets that we talked about before. We do need to decide which targets do we want to run on in order for Kotlin to know what does it need to do, like which where would it need to run on, which bytecodes or machine codes would it need to turn into, and what can we do? How do we do that, and how can we do it? So there's a list of the supported platforms with a name of each platform that we can use and add to the Gradle when we set the targets that we choose. So the JVM Android JS, as I mentioned before, the native, these are currently the supported platforms in native. As I mentioned, for us, for example, we knew that we would need to write things for Linux and for macOS and things like that. Yeah, and as we heard, there will be more supported platform super soon. So that's exciting. So all of those, you can actually use them. You need to decide which ones do you want to run on. And then you would go to your Gradle file, open a Kotlin clause, and say, hey, I'm going to run on JVM, Android, and so on. So the JVM, for example, what I have here actually selects the default preset for running on the JVM. What I can do as well for each type of target is like I did with the JS, to give it a name, a specific name. So in this case, Node.js, I give it a name. And then in this class, I can add some configuration or specific things that I want to add when I choose how to run and how would it work. It also means that you can set different names and then like have different targets that are kind of the same type. So so for different JS targets or different native targets, you can actually have multiple of those. You can just set them up like this. So this is one example. For Android, the way it would work is first you would add an Android target. Another thing that you would need to do is to add a plugin that tells the project if it's an application or a library or an SDK that you're writing. So that's something that you need to do, and don't forget and don't miss. And also then later on, you'll have an Android clause, the same one that you use, the Android developers of you here in the room. So you also have that. That's a separate one where you set up your target SDK, min SDK, all of that. You have that as well in a separate clause. Okay, so that was the targets. We said, okay, we're a multi-platform project. Second, we said, okay, we're going to run on this and that targets. The third thing would be to add source sets. So the source sets are the specific assets, the specific dependencies, the specific libraries that we want to use per component or per target. What does it look like? So I'm going to open a source set clause in my build Gradle. I'll have there, so as you saw before, as you see here, we have Android and JVM as an example for targets. I'll also always have a common clause. And there I can add all the dependencies that have to be platform agnostic. Let's see, we'll see an example in a second. Now, what actually happened, it's not just one source set per target. By default, you have two different source sets for default or like production. This is the main. And the other one is test. If you need more flavors, there are more ways that you can do that. You can add more flavors and have more different source sets per target. These are the default ones. So it means that you can separate the dependencies and the assets that you use per testing and for the testing and for the production. This is what it means. And the next thing you would do is you would open the clause and would write like you're used to be writing in Gradle for the ones who know that. Adding your dependencies. So as I mentioned before, in the common, anything that is common in the common target, you only can add things that are platform agnostic. So the stdlib, for example, is stdlib common is common, is shared. I'll show you a little bit later how you can find the things that are platform agnostic libraries or packages that you can use. But here you can have the things that are platform agnostics, as I mentioned, and then in each target, you can add the source sets that are specific for the platform, and you can add there whatever you want. So it can be either platform OS specific thing. So like here, I'm adding the Android X, so it's a native Android thing that I can add, library that I can add, but I can also add third-party libraries. So the same thing as I would have done with my normal Android app. I can add whatever I want here, like I'm used to. the project structure would be of that sort. So you'll see on your source, you'll have a root folder, a source directory, and then for each source set, you'll be actually able to see a directory with all the files, with everything that you included, the assets and everything in each different file. All right, a little bit about how we communicate, let's say, between these different levels, or between these different components. So how the app can use the common, so how the target or the platform-specific code can talk with the common code. So, as you might guess, this is something that's supposed to, and it actually comes naturally, because this is the whole point, right? We share code. It means that we have to just be able to use it from any specific place that we wanted. So in this example that I showed before, you have the on new event callback, and then we have the common code, and then we have the platform-specific code. So the platform-specific code can just talk to the common code and just get whatever, use all the methods and do whatever it wants with it, as if it was just a part of that same library. So this is a small example. The code does not really matter here. It just matters, that we'll understand when we see just a relationship and a bit of how it works. So as I mentioned, in the app, we'll have this callback. So I have kind of a listener in the Android case that inside the listener, I have the callback on custom event, or like a new event that comes in. And then I can ask to process the custom event. So the process, remember, it was something that we wanted to share. So in this case, I can just go to the common main directory and implement the method there. And I can use it from the app with the target-specific code as if it was just the same and a part of the same code base, because it is. So, so in the common main, I'll have the process custom event. Then I can do whatever I want, whatever I need with a shared code. In this case, for example, as I mentioned, I will parse it. So I have a library for serialization. So here's the JSON serializable, and then I can use here I use the main. I say, okay, I serialize it, and then like I do kind of a sorting. Okay, if it's this kind of event, the item added event, I'll send it to the presenter to do its thing, to handle it as a new item. If this item is a text, for example, like a new message, I would take it, I would sort it, and I would sort it in a different way, send it to the presenter that will handle the message. Now, what is this presenter? This presenter is an interface that I can, and this is kind of a good practice to just write these interfaces in the common models, and then, if possible and when possible, to just implement implement it in the different targets and the different methods. So in this case, in my app, I can just implement that, the handle new message. And this is just an example to show you. This is a recycler view that I tell the adapter, hey, please notify, please change the view. So this is a very specific Android code that I can do on my app. I cannot do it in the model. Yeah, I skipped the iOS. The iOS would be the view controller and so on, with very specific platform, specific platform code. Now, what if I want to skip the presenter? What if for some reason I don't want to, or I can't pass a reference to it from the application, from like the specific platform code? What would I do then? Or in other words, how the common code can talk to the app. So before we saw that it's very easy for the app or the target specific code to talk to the common model, but how do I do it the other way around? So if the common model needs to talk to the app and to reference it. So in order to do that, we have this mechanism in Kotlin Multiplatform with two new words that are expect and actual. Let's see a bit how that works. But before that, I want to say just a word about architecture. There are so many different patterns for architecture. This is not a talk about how to architect your app. There are so many different reasons and different needs for different applications, so I'm not here to talk about that. But for many of these patterns, there are some, not for all of them, but for many of them, we will find some structure like this, which I like to think of my app when I architect it, is in one way or another, these three different layers. One is the presentation, the second is the domain, the third is the data. So just a word about what each of these are and how it fits with the multi-platform topic that we talked about, that we're talking about right now. So the presentation, what can you do? It's a very platform-specific code. As we saw, it's when we want to change the views or things like that, it has to be very, very specific for the platform. So the views, the UI models, which are models that this is how I do it at least, that it's models that allow the view, it serves the view in order for the view to be as stupid and as simple as possible. So I have UI models that I create. Those mostly would need to be platform specific. On the other side, we have the data. The data is something that is very objective. This is how I think of it. Something that you, the targets, the apps, cannot really change. So in our case was the conversation data model that I showed you. It comes from the backend. Many times it would come from different services, so not even from your company, that you cannot really change that. So therefore, I think of it as like the objective truth of the reality that we need to work with. So the data, most of it would be on the common code, on the common model. And there we'll have data models and like the conversation, and also repositories, which would help us to do crude create, retrieve, update, and delete methods for the data models. So this is kind of how I think of it. And the domain layer would be the thing that would allow these two layers to talk between one another. So the expect and actual pattern comes here in order to help us talk between those. In the domain layer, I call it use cases, other people call it interactors, but essentially these are the action, the functionality that our apps want to do, mostly. We'll see one example of this use case is to add an item. So we saw the list before, and let's say I want to add a new item to the list of things I want to buy. So once again, it's a very high level. We don't need to focus on the code so much. It's just to understand the idea. Probably what I would have, this is an option, to have something like this. We'll have a button to add a new item, and I'll set a listener to it, and then inside of it, I will take the UI model that I talked about before, and then would execute the add item use case or interactor that I created with this item name, with a new item. So this is how I add a new item that someone created in the application. So what is this add item use case object? What would it contain? In the common library, in the common code, I would say, okay, we're gonna execute a new item, meaning to add a new item with this name. So we're gonna execute it. I don't know why it does this thing. And the way it would happen, it would just create a new JSON, so we'll create the new event, and then send the custom text in this case, or like to add a new item for a text message, for example. Now, what is this send custom text method? This is something that each platform would need to decide. So what I can do in my common model is to say, hey, I'm the common model, expect that each platform, each different target would know and would implement this method, the send custom text method. And then in the Android part, I would need to open the same file. This is an important piece. Like, we would need to add in the same location. So in the Android, I have add item. This is the same file name. And then I would need to implement the method with the same signature with the word actual. So this is the actual implementation of what the common code expected me to do. So this is how I actually send the custom event. So this is just an example. Here I do send text. I use like the platform-specific SDK in this case, and I send a new text. In iOS, we would use the platform-specific SDK, and we would do, in this case, it looks kind of the same. But let's say if I would want to do the same, like SDK with the same functionality for the browser, it would look a little bit different. And in this case, for example, I might not use a native SDK, but I would do a network call to our API, to the backend API, and ask the backend API, to add a new item. So it could be a totally different implementation. And this is what the expect and actual allows us to do. So the most important things here to remember are two things. One, you have to use the same location when you use the expect and actual in the different directories, so in the common and in the different targets. And the second thing, to use the same signature. It means that here it was easy for us to do because the parameter here is a string. So all of the platforms know what's a string and that they can use the string. If you need to use an object, a different object, if it's Kotlin and you can do it in the common code with platform agnostic, it's all good. If not, then you would need to do an expect and actual for the class itself. So for the object itself. All right, we're going to finish in a few minutes. Just a little of what can you use right now. So as I mentioned, I don't know if you can, you can say it pretty good in the packages if you look at the packages in the Kotlin documentation, you have these small chips. So you see like right now it's like different dots, colorful dots. If you hover, then each of these dots would tell you which platforms does this package support. So the blue one, the left one, is common. It means that it's platform agnostic. You can use it whenever you want. So that would be helpful for you to understand which type of packages you can use. So that's from the documentation, from the Kotlin documentation. And also there are many, there are libraries, and we see more and more libraries that are being added. Here I used the Kotlin X for doing serialization. You can use coroutines. We use it, I think, as well. SQLDelete for SQL, so for the databases. So you can use it as well already in Ktor, and more and more and more. So you can look at it on GitHub and see there's a lot of new things going on there. So check it out, and the ecosystem is showing us a lot of new libraries and packages all the time. So it's time to be updated. So here you have some sessions from this conference today and tomorrow that you can check out for multi-platform, native, JS, and so on. So if you want to deep dive into any part of the things that we talked about today, you can do that. There's also a hands-on lab in order to help you to get started. That is both today and tomorrow. So if you really want to get started, I do recommend you. As I mentioned, the getting started bit, it's like the configuration, it's the hardest part. So this could be a good opportunity for you to attend. That's it. In order to just sum up what I showed you today, a little bit of how it works. I'm here and super happy for more in-depth questions. Remember that you can share what you want, when you want. You don't have to do like very big steps in order to get started and honestly to see the value that you get from this type of project. Remember that for the time being, it's still experimental, which is, to be honest, what it means, it's not that the platform or the technology itself is not stable or anything like that. We saw in the keynote a lot of applications are actually out there in public with this. Mostly it means that you kind of need to be prepared to explore and be prepared to look at documentation that maybe would be a little bit outdated and so on. Good news is things are happening all the time. You have the community Slack for Kotlin, so use that. It's been super helpful for us. So this is mostly what it means, so that you need to be ready for that a little bit. But as we saw in the keynote and in the content of this conference, this topic becomes more and more popular. Kevin Galligan says it's popular in a good way. I like it when he says that because it means that we all, in a stage where we support one another, we see that a lot of people are very much interested and write for it and write with it. And these are good signs that a lot of good things are gonna happen. It's a really good time, I believe, to jump on the ride and take a part of this journey. Keep sharing your code and with the community. Keep caring for one another. I really want to thank you very much for being here, for your time, for your energy, for your attention. I'm here for questions. I should mention that also if you want to join us to our in our company Advantage for our Kotlin Multiplatform project journey and more, then come chat with me. Super happy to chat here or on Twitter. And that's it. Remember to use the application to vote for this session, for other sessions. Have the best KotlinConf ever, and see you around.